I hope you're all refreshed and ready for our next presentation. Now it's my pleasure to present Christine Cunningham, Professor of Education and Engineering at Penn State University. Christine's work focuses on making engineering, science, and computational thinking more relevant, accessible, and equitable, especially for populations that are underserved and underrepresented in STEM. Her presentation is titled Engineering in Early Education.
STEMIEFest is pleased to welcome Dr. Christine Cunningham, Professor of Education and Engineering at Pennsylvania State University. Dr. Cunningham's presentation is titled Engineering in Early Education.
Welcome to Engineering in Early Education. In this session, we are going to think about the E, engineering in STEM. We'll explore what this might look like in early education. My name is Christine Cunningham. I work as a professor of practice at Penn State University. My work focuses on how to make engineering and science more accessible and equitable. I've been thinking about how to engage children from preschool to high school in engineering for over 20 years. Today, I'll share some of what I've learned about engineering in early education. I want to start by briefly thinking about what engineering is. What do engineers do? How is this different from and related to science? I find it helpful to focus on what the goal of engineering is. Engineers aim to solve problems. Engineers design things to solve such problems. As they do so, they draw on their knowledge of science and mathematics, their understanding of materials and their properties, and their creativity. For example, engineers design toothbrushes, bicycles, processes to clean drinking water, traffic intersections, and smartphones. The objects, processes, and systems that engineers create are called technologies. People, including young children, naturally design and shape the world around them. They build towers, sandcastles, forts, and beds for dolls. Young children are intrinsically curious about the world around them and like to help people solve problems. Let's think for a few minutes about how we can harness these designing and problem-solving proclivities and nurture them in young children. Doing engineering is more than making stuff. Young children make a lot of things, but just making something is not engineering. In these projects, children are practicing skills like painting, drawing, gluing, matching, and following directions. These skills are valuable. But to be engineering, the activity needs to be more than just building or creating. Engineers are solving a problem as they design and create. They engage in a problem-solving process and consider the materials they use and how their designed product meets a goal. These are core features of engineering. What do they look like with young children? Often engineering problems start with a goal. What are you trying to accomplish? How will you know if you are successful? As children engineer, they should know what they are trying to achieve. The problem should be familiar to them. For example, preschoolers might be asked to design a boat that holds weight, or they might design a pillow for a favorite stuffed animal, or create a ramp that moves a ball or marble along a certain path. Importantly, the children should understand not only what the technology is, but how it needs to function. What does it need to do? For example, a pillow should be soft and fit on the bed. A boat needs to float. Educators can help children understand the problem and how they might test it. Introducing the problem in a larger context and connecting it to children's lives with a narrative context can make the problem more meaningful. For example, a narrative might explain that a family wants to visit their grandparents who live on the other side of a river. It can invite the children to help design a boat that will help them cross the river to do so. Engineers use a problem-solving process called the engineering design process as they do their work. Early engineering can help children develop facility with an iterative process. As they engineer, they engage with different kinds of activity for different purposes. Naming these phases can provide children with landmarks and help them recognize the kinds of work they are doing. Here are some examples of age-appropriate design processes for preschoolers. In general, children start by exploring their world to understand some of the basic principles that underlie the challenge. For example, which materials are soft? Which shapes best roll down an incline? Materials-rich, hands-on investigations help children develop a deeper understanding of the problem. Then they construct something. Children are very creative. Engineering problems should allow them to generate many different possible solutions to the problem. Many children will immediately want to try or test their design. Their designs may not work well the first time. Usually, children will want to make changes to the design and engage in an iterative process of designing and testing until they are satisfied with the results. Educators can help children think like engineers by asking questions about what they noticed during exploration and testing. They can ask children to describe their design or explain why they are making the choices they do. Such questions can help children reflect and share what they are doing. Another core idea of engineering focuses on materials and their properties. Materials all have properties. An object might be fuzzy, strong, shiny, and so forth. The properties help determine how the material behaves under certain conditions and how suited it is for particular tasks or designs. As children design solutions, thinking about which materials they might use is an important step. Knowledge of materials is something that children need to develop over time through hands-on interactions of and manipulation of materials. This is a big part of what young children should be doing. Through physical manipulation and exploration, children come to understand which materials are, for example, soft, heavy, slippery, or waterproof. Before creating any technology, all youth, but especially young children, should have experiences that actively build their understanding of the materials that are available for their designs. Children should be introduced to the materials they will use in a challenge. They should hold, explore, test, observe, and describe them. As they investigate, educators and caregivers can introduce vocabulary associated with the material and their properties. Which are soft? Why is something shiny a good choice for that design? I mentioned earlier that introducing engineering design, when you introduce engineering design challenges, you should include key performance attributes. For example, a bridge needs to be strong enough to support a toy car or a small doll. Noting characteristics of successful designs helps signal to children which properties are important for the task at hand. Here I summarize some of the attributes of high-quality engineering experiences for early education that I have mentioned today. Engineering problems should invite children to work on a problem they are familiar with. To be age-appropriate, the technologies they design should be simple. Children also benefit when engineering activities are set in a larger context, particularly one that has a narrative thread. Engineering problems have multiple solutions. Children should be invited to bring their creativity and address such open-ended problems. Materials are really important to design, so children should explore materials. The materials they interact with should help develop understandings of important characteristics of the technology. A simple process can be used to scaffold children's work. And finally, as they engineer, children should reflect and share with an educator or with their peers. Let's see some of these principles in action in preschool settings. This first video comes from WGBH's Little Peep collection. In the classroom, children are exploring ramps. As you'll hear the narrator explain, she has adopted an approach that allows children to explore attributes of ramps in various centers. You'll see children sorting objects by how they move down the ramps, roll, slide, or stay still. In another center, children engineer ramps made of blocks and tubes. In a third center, they explore how the incline of a ramp affects movement. And they also make connections to art and literacy. This video provides a very quick glimpse of the ramps unit. I encourage you to view the more extensive videos and resources for this and other engineering-related units online.
At one of our learning centers, we tested if objects placed on a ramp would roll, slide, or stay still.
This one rolled.
At another center, children could set up marble tracks and create ramps with blocks.
That was close.
At our third learning center, we set up a tabletop experiment similar to our roll, slide, and stay in place center. But this center allowed children to change the steepness of the ramp.
Cool.
We also created an art center where the children could create paper roller coasters and draw ramps and tracks. And of course, at our book center, we added books on ramps, rolling, and movement. At our roll, slide, and stay in place center, we experiment with different texture ramps.
Did it go down smoothly?
Down bumpy.
And at our marble track center, we give the children challenges like getting the marble to land in a bucket.
All right, let's try that.
Beautiful.
Did you notice how interested the children were in meeting the goal of getting the marble into the bucket? And how they changed the design of their track until they designed something that met that goal? Similarly, you may have noticed the children actively exploring materials and their properties, especially in the roll, slide, and stay still activity. There were many variables here that they investigated through experimentation. What was the object made of? What was its shape? How did the surface of the ramp affect movement? These are all important features in thinking about whether and how objects move. Let's look at one other video from the Science Beyond Boundaries from the St. Louis Science Center. This video demonstrates an engineering activity that can be done with young children. The children will design a boat that can hold weights. This activity is a simple engineering activity. Even so, it includes features of engineering with young children. I invite you to also think about additional supports or extensions that you could include that further reflect some of the best practices. For example, could this activity be set in a narrative context? What other materials might you make available for children to engineer a boat that would help them explore important properties of the boat? Paper, fabric, clay perhaps? Children are natural engineers. I encourage you to tap their creativity, curiosity, and problem-solving skills through design-based activities. Thank you.
Now it's time for Q&A. Dr. Christine Cunningham, Professor of Education and Engineering at Pennsylvania State University, will be answering questions about her presentation, Engineering in Early Education. Becky Chance is the moderator. Christine Cunningham, Ph.D.
Thank you for introducing us to some engineering in early childhood and explaining the core features and strategies for implementing STEM in early childhood inclusive settings. I'd like to go ahead and open up the floor right now for our Q&A session. If you have a question for Dr. Cunningham, please type it into the Q&A box at the bottom of your Zoom toolbar. Dr. Cunningham, we have a question asking, these engineering-based activities, are they for a specific age group or are they for middle school?
So the WGBH Little Peep series is a series designed for preschool and primarily preschool. So that those are specifically designed for children that age. The St. Louis Science Center activities I'm not as familiar with, but the little work I did and looking around online indicated that those are available for young children, but could also be used with older kids as well.
And a follow-up question from the same person. We do engineering daily, but we call it STEM, correct?
Yes. So that's a very interesting question. And STEM does have engineering in it. And certainly engineering is very closely related to science. So as I work with educators and parents or families, generally people, to think about how do we know it's engineering or how do we know it's STEM, I like to think about the goal of why we're doing a particular activity. Each one of the disciplines in STEM is a kind of thing people have made up. It's not a real, you don't go to college and major in STEM. You don't go to do your career and be a STEMist, you're a scientist or an engineer. So we've looped those disciplines together because they have similar attributes, but in essence, while they overlap, there are also some really specific elements that make them engineering or science or mathematics. So for instance, in engineering, the goal is really to design a solution to solve a specific kind of problem. So that's in the kind of work we saw today. If the children are trying to make a boat or kids are trying to make a pillow or someone is designing a way to make a safe intersection, that would all be in the engineering domain primarily. In science, what the goal of science is really for kids to understand, observe, describe, and predict the natural world around them. Many of the disciplines intersect. Like ramps is a particularly difficult one because it is both engineering and science. Kids are learning a lot about how the world works, but if they have a particular challenge or goal to design a ramp that will move a marble a certain distance or result in it moving into a pail, I would call that particular part of that experiment engineering. Along the way, they may also be doing science explorations that help them to build their knowledge about their world so they can then use those as they do engineering. But admittedly, as you get younger and younger, the boundaries between engineering and science tend to blur a lot. And even in the real world, people go back and forth. But it is a very interesting question. And you're absolutely right. You and the young kids are doing STEM, in their daily lives constantly.
Thank you. So with young children, how can we assess them with engineering?
That is an interesting question. One of the things that we like to focus on is helping people understand that the assessment should focus on the processes that the kids are engaged in and not the product. So there is a natural desire to make something that works, and certainly that's part of the equation. But what we are more interested in is whether kids can design something, can look at it and think about or describe why it's not working or what they might do to make it better. And so having that kind of active engagement and interaction with some sort of next step or learning that takes place along the way is much more interested than or much more beneficial to students than deciding that one child made a bridge that held 5 dolls and one could only hold 1 doll. And so everyone has to try to make a bridge that makes 5 dolls, because that's not the kind of thing we should have kids focusing on. We should be really focusing on how they can ask good questions, how they can design some experiences that will help them meet those challenges or goals. And then when it doesn't work, how do we engage them in sort of the persistence in their learning so they'll try again, try something different, and then observe, describe, and continue to move their solutions forward. So it's really much more about the process than the product as the focus of whether or not they're doing good engineering when we go into settings.
Do you have suggestions for ways to get caregivers to participate in these types of activities?
I think one of the biggest challenges that we've encountered with particularly folks who teach young children, whether that's elementary school or preschool, is that there's a fear of the word engineering, and they think it's a big, complicated thing that needs calculus and really complicated materials. But I think helping people understand that we as human beings naturally engage in a problem-solving sort of engineering process, and starting there and building on those, towers that kids build and knock down is one way that we can help educators understand, like someone mentioned previously, we do this all the time, we just haven't called it engineering. So I think if you can start doing that, that's important. I think using the term engineering is important. I had a lot of discussion with educators when I started this many years ago, before engineering was something anybody did at preschool. And they would say, oh, it's a very big word. And there are many big words that young preschoolers know. Many of them can talk to you about Tyrannosaurus rexes, and that's a very long word. So it's not that the word is long, it's that it's used in a way that the kids come to understand what it is. So I think identifying what they're doing as engineering or problem solving is important. As I mentioned in the talk, the other thing I think that's very important with preschool educators, because it's so much a part of what kids should be doing at that age, and so very important for children to do as they scaffold through their education, is to focus on materials and their properties. So really developing an active, manipulative sense of, what does it mean to be fluffy? What does it mean to be smooth? And I think the more that educators can have kids, work with materials and have an active building of the association with certain kinds of properties, with certain kinds of materials, that's very helpful for kids, because they have lots of misconceptions that they come into challenges with. And I'm sure you'll see them, like they have their favorite materials. For instance, we found that in our work that pink smiley face erasers work for absolutely everything when kids start. They like the looks of it, and it doesn't matter if you're trying to make something strong or make it float or make a pillow, they want to use the pink smiley face erasers. By working with kids to think about what properties do we need to have our device do? What does a pillow need to do? Well, good pillows are soft. We can get the kids, after they've tried the pink smiley face erasers, because they just can't help themselves, to think about, okay, what are some other materials that we might use instead in our pillow to make it soft? And I think that back and forth with helping kids recognize that the challenges have properties, and that you can use certain things to meet those properties, making that connection so it's not just about appearance, but about the function is something that preschool and early child care folks can help children develop.
Great, thanks. Could you please provide some tips for educators who are just getting started with engineering in preschool? Any other resources that you might suggest that they're freely available to support educators in learning more about early engineering?
Oh, good question. So I've found WGBH has a bunch of stuff. There's some other, I always go to the Google Online. So I'm not aware of a whole bunch. I can do a little bit more searching, and there's a little bit here and a little bit there that if you look at young children and engineering, you'll find materials. I know that the Teach Engineering site has resources, but I don't believe they go as early as preschool, because preschool is relatively recent in engineering. I think if you do the Google search, which I did a couple of days ago, I think one of the important things from the educational point of view is helping the kids to think about why they're developing something and trying to situate it in a context. So as I mentioned in the talk, going beyond just making to actually solving a problem. So for instance, you'll find sites that have kids connecting gumdrops with toothpicks. Unless there's a reason to do that, my suggestion would be that is a less meaningful experience for children than perhaps designing a bridge that goes between, two sets of books. Because one of them they can connect to their lives and start to think about, like, what else do we make in our society that is engineered? And the other one is, to some degree, more of an arts and crafts project or a have fun project, but that strong connection. So I think looking online and then applying some of the lenses of what is the problem that it solves, does it help kids think about materials and their properties? Is this something that young children are familiar with and can make that personal connection? Are sort of three things that I would apply as I look through things online to try to find some activities.
What is the difference between learning engineering and developing problem-solving skills?
So I think you can have lots of different kinds of, a lot of different occupations and folks solve problems. Medical doctors solve problems, and construction workers, one could claim, solve certain kinds of problems. And I think at a very young age, it becomes a little blurry, because some of the nuances have to do more with the kinds of skills that you bring to the problem and how much science and math and replicability you can do. I would say for young kids, in thinking about the problem, if there's a goal that they're trying to create, that there's some part of the physical world that they live in that has a connection with it. So you could say, for instance, that we need a pretty picture for our wall, and that's a problem, and kids create a work of art. But to me, that's would fall more in the realm of art than engineering, because there's not a connection with the physical world that the kids have to look to the world that they live in to solve that problem and bring those science and mathematics principles. And again, it's very murky at the young levels, because the activities are so basic. So I think the other thing that I would say, sort of to highlight, is the difference of engineering and problem solving potentially, is that there is a process that has some different phases, and that folks go round and round and round as this iterative cycle. And so instead of sort of willy-nilly just trying everything, what engineers are supposed to be doing is thinking about what they know, or exploring the world around them to learn something about it, thinking about possible ways they could solve the problem, and then testing and gathering some sort of data that then informs the design. Now, with 3 and 4-year-olds, that can be a somewhat tenuous proposition at times because they're still developing a lot of those sequential thinking skills. But encouraging children to think in that kind of way and encouraging them to make decisions or giving them the scaffold so that they can think about which materials are fluffy or which materials are waterproof. I would argue would lean it more toward an engineering activity than perhaps some of the other problems. We need to pick up our books. I mean, there's a problem if we need to pick our books and put them away, I would say is just a problem-solving process. That's a problem. We can solve that. If we need to design something that helps carry the books that we need to put away from the book table, that in my mind then becomes more of an engineering process because you're creating a tool, an object, or a process to do that. So there is a very close line, and I don't think it needs to be hard and fast. And certainly the educators we work with often to their students talk about a problem-solving process that they use for mathematics and they use for writing as they get older, and they use for engineering. But there are certain features I think you can emphasize if you want to make it more of an engineering process.
We have Eve shares with us that some experiences from her. She said she found that she's able to fix a lot of electrical things like the garage door and the microwave, but she never went to school for engineering. So her question is wondering, how do we know when and how and strategies to guide children towards that profession? And because obviously there's these engineering skills we need to be tapping into. So what's some ways we can guide children towards that?
Yeah, that's a really good question. And I think one solution is, as I mentioned early on, having kids calling it engineering. So part of why I think children don't think about engineering as a career profession is because they don't know that they're doing it. They've never been told that they're good at engineers. So we encourage the educators we work with to say to their children, you were great engineers today. Let's go engineer a pillow for a child. And I think using that word and then creating that sense of identity with the young children is one way that they can think about this as something that they're good at and that's something they might do in the future. For really small preschoolers, they talk about things in general. They want to be firefighters or movie stars or whatever they want to do. But as kids actually start to think more seriously about their careers, I think connecting them to actual problems that engineers solve in their world and giving them real examples that the role models we know is very important. We know that parents, from some previous work I've done, we know that parents are extremely important in their students' or their children's career decisions. And so we always try to connect with parents and let them know and call what their kids are doing engineering. So we might send a letter home and say, we're going to be, engineering a fill in the blank this week, a set of balls and ramps. Sometimes that's the same letter. We invite parents to send materials, and we might be collecting like old soda bottles or empty toilet paper tubes or whatever we're using. But by explaining to the parents that their children are engineering and inviting them to have a glimpse into that world, I think they can continue to support their kids if they come home and said that they're interested in or have these kinds of, they really enjoyed engineering. So I think parents are one very, very important space to go. I think they're also continue to have a building bunch of books and museum exhibits, and there's now a bunch of children's television series that mention engineering. So I think that identifying, affiliating is a big part of it, and then giving the kids the activity, the experiences themselves. There's nothing like doing something and feeling like you're good at it, and then having that labeled engineering to encourage kids to think about that as something they may want to do in the future.
What are some common engineering play and work preschoolers that are doing already?
Oh, that's a good question. So some of the things that we see in preschools, they often have activity stations. So certainly if there's a block station or a building station, kids use blocks, or they use, the older ones might use, large Legos. That kind of building towers or building structures or building systems. There's a lot of engineering thinking that goes in just to figure out how do you get things to stack. And the fact that if you have a wider base, eventually kids will figure out that if you have a bigger base, then the things tend to be more stable. So I think if there's those kinds of spaces, there's some engineering that can also happen as kids are engaged in water play. I know water stations are another thing that kids often use in preschools or even at home in their bathtubs. So if you have, toys and things they can manipulate, how does water go into one thing? How does water flow? How can you change the design of water flow? So, children, as they splash around outside and streams, even they like to build their dams, and they watch and see how it goes around. And then they figure out, how do you put rocks or leaves or something to change that movement of water. I think that's another space that we see kids engineering. Certainly, sometimes in the if they have a sand table or something like that, where kids are building or designing, complicated systems to, holes or places that you might send water. All that connecting of the different shapes and elements is another space that you can see some engineering with kids. Certainly, I don't know if balls and ramps is just something in the preschool, the Little Peep, but I've heard a number of educators say that's another thing that they often do with their kids, rolling things, thinking about how things move and what moves. That kind of thinking is all engineering thinking that kids are doing already in the preschool settings.
Great. Thank you so much. We want to thank you, Dr. Cunningham, for sharing with us more about engineering and early childhood STEM. And thank you to all of our participants who've asked some great questions. And thanks for attending and learning more about engineering and STEM with us.